Hello, mathematician, and happy summer. I hope you're doing well. In this video, I'm going to show you some sample problems that go along with each type of problem that you'll encounter in your Summer Algebra 2 packet. So, have your packet nearby, whether on a screen or on paper in front of you, so that you can follow along with the steps that I do on my problems and apply them to your problems. Let's take a look at the first type of problem. Evaluate a function. In this problem, you're given a function rule like h of n equals n squared plus 2n, and you're asked to find the output of a given input. In this case, find h of negative 7. So what is this problem asking us to do? Well, it's asking us to take the h rule and see what happens when we put negative 7 into that rule. Let's see. H of n is n squared plus 2n. So h of negative 7 is going to be the same rule, but replacing all of the variables with this input of negative 7. So in place of this n, I'll put a negative 7. I keep the squared, I keep the plus, I keep the coefficient of 2. I have another variable, so this n gets replaced by negative 7. So h of negative 7 is this expression, which I can simplify. I can either do the operations by hand, following the order of operations, or I could have a calculator do the arithmetic for me. I'm going to show how the calculator would do it. I'm going to plug in everything on the right side of my equal sign. So parentheses, negative 7, close parentheses, squared, plus 2 parentheses, negative 7, close parentheses. And that gives me an output of 35. So I can conclude that h of negative 7 is 35. And that's my final answer. So to recap, I read the function rule. In this case, h of n equals n squared plus 2n. Then I look at the input. I'm supposed to input negative 7. So I take the rule and replace all of the n's with negative 7's. Once I have an expression that uses only numbers and operations, no variables, I can simplify that by following the order of operations by hand or by typing it carefully into a calculator. Either way, I should get an accurate output. In my final statement, h of negative 7 is 35. So, pause the video, re-watch it if you want. Try your problems that ask you to evaluate each function. Once you feel good about the evaluating function problems, you can unpause the video and we'll take a look at the next type. Type number 2, find each product. In this type of problem, you're going to be multiplying binomials. We may have remembered this as box multiplication. So my problem is parentheses 7b minus 4, close parentheses, parentheses 5b minus 8, close parentheses. What I've got here are two polynomial factors. So my first factor is being multiplied by my second factor. I'm trying to find the product. What is the simplified result of these two things being multiplied together? Well, we can use our box strategy to find out. I'm going to make a box, and on top and on the left, I'm going to have enough space for each term. So 7b and minus 4 can go fit nicely in the left, and then 5b and minus 8 fit nicely on top. So I took these factors and wrote them outside the box. The next thing that I need to do is multiply. 7b times 5b will find the product and put that in the first box. 7 times 5, that's 35. And b times b, well, that's b squared. We'll continue multiplying to fill in the rest of the box. 7b times negative 8. Well, 7 times negative 8 is negative 56. And b, well, there's only one b there, so I get to keep the b. Next box, 5b times negative 4. 5 times negative 4 is negative 20. There's only a single b, so I leave it as a plain b. Finally, negative 8 times negative 4. The product of negative 8 and negative 4 is positive 32. Now that I have all these products in the box, I need to combine like terms. Right now, I've got a 35b squared minus 56b minus 20b plus 32. However, I've got these like terms, a negative 56b and a negative 20b. They're the ones that showed up in that same diagonal with the same type of variable, a linear b. I can combine those. I can do the operation as written. Ignoring the variables, I just see negative 56 minus 20. Perhaps I use a calculator to help me with my arithmetic. Negative 56 minus 20. Negative 77, you know what? That makes sense. Since I'm adding and subtracting, combining, I started with a negative and then combined it with another negative, it got even more negative. So my final response, the 35b squared didn't change. These linear terms combined into negative 76b, and this constant stayed as plus 32. That's my final answer. The product of these factors is 35b squared minus 76b plus 32. To recap, I built a box. I put the terms outside of the box. I multiplied into the box. And then I took those products and combined like terms to get my final answer. Pause the video, rewatch it if you want to, and try your problems now. Once you're finished with your problems, unpause the video and move on to the next type. In the third type of problem, you are combining polynomials. In other words, you're combining like terms. The instructions say simplify each sum. We've got this polynomial expression. It's not in simplest terms, and it's not in standard form, so we need to get it there. Our goal is to arrange this polynomial from highest degree to lowest with no like terms. So first, let's organize. Let's see, I see a 5v, a linear term, and another linear term, a plus 6v. Let's see, we have a plus 4v to the fourth. No other quartic terms. What about cubic? I see a negative 7v cubed and a plus v cubed. And finally, I see a quadratic term, negative v squared. So I need to combine all of these. I'm going to start with the highest degree first. This positive 4v to the fourth. There are no other quartic terms, so I get to just start off with that, 4v to the fourth. Great. Now I need to look for cubic. Negative 7v cubed plus v cubed. I might remember that the invisible coefficient is 1, and that can help me with my arithmetic. I'll combine those like terms. Again, I can use a calculator to help with the arithmetic. Negative 7 plus 1 is negative 6. So for my cubic terms, I can have negative 6v cubed. All right, those are taken care of. Moving on to quadratic. Okay, there's just the single quadratic here. Can't combine it, so it stays the same. Negative v squared. And then I've got these two linear terms, 5v plus 6v. Well, 5 plus 6 is 11, positive 11. And those were linear terms, so we'll have a plain old v. That is my simplified polynomial in standard form. To recap what I did, I identified the different types of terms in my expression, and I organized them from highest degree to lowest degree. I combined like terms by using arithmetic, addition, or subtraction, following the signs exactly as written. I checked my work to make sure that my degrees went from biggest to lowest, to the fourth, to the third, to the second, plain old v. You might also have a problem that has a constant, a number with no variable whatsoever. That would go last. So pause the video, rewatch it if you want, and do your problems. When you're satisfied with your work on this type of problem, unpause and move on to the next type. In this type of problem, your task is to factor a quadratic trinomial. My problem is x squared plus 17x plus 42. I have this quadratic polynomial written in standard form, but I want to rewrite it in factored form. A tool that I find useful is our factor pairs chart, which you can find at the end of this packet. Let's take a look at how I would go about factoring this expression. I notice that I have a quadratic trinomial, and I remember that one of the strategies that we've used for this is to do the x game. So I'm going to set up an x game where I need to find a pair of numbers that multiply to this last number, the c value, the constant, but combine to this middle value, the b value, the linear coefficient. So I need to find a pair of numbers that multiply to 42, but combine to 17. So I can use my factor pair sheet to look up all of the integer factors of 42. Let's see, could it be 1 and 42? Well, they certainly multiply together to get 42, but if I combine them, that's 43. That doesn't work. I can try that out with the rest of these factors. 2 and 21. Multiplication works, but addition gives me 23, not what I'm looking for. 3 and 14. Again, it multiplies to 42, but does it add up? Oh yeah, 3 plus 14 is 17, exactly what I wanted. So my magic numbers are positive 3 and positive 14. Since I have found these magic numbers, this m and n, I can plug those in to factored form. Factored form is going to have a pair of polynomials multiplied together. I'm going to use the variable that I see in my original quadratic, in this case the x. That will be the first part of each binomial. And then I'm going to plug in those magic numbers at 3 and 14. It was a positive 3 and a positive 14. And that is my final answer. This quadratic trinomial in standard form is equivalent to this product of linear binomials. The factored form is the quantity x plus 3. times the quantity x plus 14. So to recap, since I saw a quadratic trinomial with a leading coefficient of 1, I could just use my x game. Find the pair of numbers that multiply to the constant and combine to the linear coefficient. I can use my factor table as a reference to look up all the possible integer factor pairs that make my constant. Once I found those magic numbers, my m and n, I can plug them into factored form using the variable from the original problem, parentheses, and plugging in the numbers that I discovered with the x game. Pause the video, rewatch it if you want, and do your problems. When you're satisfied with your work, unpause and take a look at the next type of problem. Let's take a look at the fifth type of problem. These are problems that involve compound interest. I'm going to read the instructions. Read each situation. Choose the best formula, identify the information, and plug in the known values. As a bonus, simplify and/or solve to find the unknown value. For this, I'm going to use my reference about compound interest formulas, the two different formulas, and a key for what each variable stands for. How about I read the problem? Paula plans to invest a sum of money in a retirement account with a fixed annual interest rate of 9% compounded monthly. After 20 years, the balance needs to reach at least $40,000. How much does Paula need to invest to achieve this goal? Let's start off by choosing the best formula. I've got two options, the finite compounding interest formula and the continuous compounding interest formula. I'm going to scan through the text to see if I see the word continuous or continuously or infinitely. Compounded monthly. That's not continuously or infinitely, so I can't use the continuous formula. I must need this finite compounding formula. So I'm going to record that on my sheet. A equals P, parentheses, 1 plus R over N, all raised to the N times T. Okay, that's the formula. Now I'll identify the information. The information that I could find is the balance, the principal, the interest rate, the compounding frequency, and the total time. Let's see, Paula plans to invest a sum of money in a retirement account with a fixed annual interest rate of 9%. Ooh, my interest rate is 9. Okay, so 9%. Or 0.09. Let's continue. Compounded monthly. Ooh, that's a clue. That's a how often word. Monthly means 12 times per year. My compounding frequency, how often. My n value, I see the word monthly, so I know that n is 12. If something happens monthly, it happens 12 times per year. All right, so monthly gave me my clue about n. After 20 years, that's time. In fact, that's the total time. The total time, t, is 20. The balance needs to reach at least $40,000. $40,000, that's in the future. It needs to reach that in 20 years, after 20 years. So that must be the amount after. So the A value is 40,000. How much does Paula need to invest to achieve this goal? The question is, how much will she invest? We don't know what she needs to start with. So the 40,000 is the A, the P is unknown. So I've identified the information. Now I can go ahead and plug in. My A value is 40,000, and that equals my P value. I don't know that, so I'll leave it as a variable. Parentheses, 1 plus my rate is 0.09 over my frequency, 12, all raised to the n, again, 12 times t, or 20. Okay, so that is all that I need to do. I chose the best formula, identified the information, and plugged in the known values. So if you want to stop here, go ahead and do these steps for your problems. However, if you're interested in the bonus, I'll show you how I would go about simplifying and/or solving to find the unknown value. If you don't want to do the bonus, skip ahead to the next section. All right, so for the bonus, we're going to need to then solve for P. So I'm going to check for anything that I can simplify. I'm going to look at my different groups and see if there are any groups that have a bunch of numbers and no variables. Okay, my first group, it's just one number. I can't simplify that. My next group is a variable. I can't do anything to simplify a variable. But my next group is a bunch of numbers. So let's see. I can do 1 plus 0.09 over 12. And that gives me 1.0075. All right. So this group is 1.0075. Then I have another group, 12 times 20. Let's see, 12 times 20, that's 240. Okay, I've done some simplifying. I haven't done anything to my 40,000, or my equal sign, or my p, but I do now have 1.0075 to the 240. And oh look, that's another group that I could simplify. All of this can be simplified, and the p is still going to be attached to it, but it's going to be simpler. So 1.0075 raised to the 240. Oof, look at that decimal. I don't want to round it too much since I'm not done with the problem yet. So I'll simplify this as 6.0091515. So now I've got 40,000 equals P times 6.00911515. Any other simplifying that I can do? There are no other groups that are just numbers and operations. The next group over here is a variable and a number, and again, we just have a number all alone. Time to start solving. So I need to look at my different strategies for solving for P, getting that P all alone. I might think about rewriting, and I might think about canceling. Rewriting this doesn't seem very useful. I don't have an exponential equation anymore, so it doesn't make sense to rewrite it as a log. But I do see that I've got some multiplication that I can cancel. I want to get P alone, so I need to get rid of this number that's being multiplied. So I can divide by 6.00911515, and I balance on the other side. 6.00911515. I'll calculate that with Desmos. 40,000 divided by 6.00911515. That cancels. This simplifies down to 6656.51. That equals p. I have isolated the p-value. Let's check if it makes sense in context. Paula was looking to figure out how much she needs to invest initially. Does it make sense that she would need to start off with about 6,600 in order to reach 40,000? Yeah, she's going to need to start with a number that's smaller than what she wants to achieve. So it makes sense to me that Paula's initial investment should be about $6,656.51. Depending on the type of problem that you encounter, there could be some different strategies to solving for your variable. Remember to look for ways to simplify and then look for ways to solve to get that variable all alone. Remember, this part is bonus, so it's okay if you want to move on to the next type of problem. Pause the video, and when you're ready, unpause to look at the next type. In this final type of problem, you're going to read a real-world situation and try to give advice. Think about what extra information does each person need to find out. Think about what they should do with that information. Then write 1 to 3 sentences of advice to help them make their decisions. So here's Janaki's problem. Janaki has 2 job interviews scheduled for Thursday. One of them is at 10 a.m. and the other one is at 2:30 p.m. She wants to make a good impression at both interviews, so she needs to figure out a schedule to make sure she arrives on time. Okay, I could give Janaki some advice for how to achieve her goal. She's got to travel to 2 different places for her interviews, and she needs to show up on time. So I would tell Janaki that she needs to figure out how long it takes to travel to each of these interview locations. I might write that as a sentence. Janaki needs to find out how long it will take to get to each interview. And what? Well, if it takes an hour to get to the 10 a.m. interview, she needs to make sure that she leaves at least an hour before it starts. So then she needs to plan to leave early enough to arrive at the interview with extra time. She might want to subtract the travel time from the arrival time. So that is one way that Janaki could go about solving her problem. She'll need to find some extra information, like how long it's going to take to get to each interview. Then she can do some mathematics to help her plan. And that's what I'm looking for this type of problem. Read the situation and give the person advice. So Janaki, you need to find out how long it will take to get to each interview, then plan to leave early enough to arrive at the interview with extra time. You might want to do subtraction to figure that out. So read the situations on your page and go ahead and give these people some advice. That's the last type of problem, so do your best, and I look forward to seeing your work. Have a wonderful rest of your summer, and I hope to see you next year. Bye!